All right, here we have another video about the ballistic pendulum, but this one's for the AP students only. And I want to ask you, actually, no, well, these are variations on the ballistic pendulum. So you'll recall that the original ballistic pendulum had a bullet impacting into a heavy weight. That weight would then swing or start moving, and that would cause it to swing up a distance h above where it was before. So the velocity of this bullet eventually becomes the height of this thing. So what happens if the bullet doesn't embed itself into the block of wood? What happens if afterwards the bullet has passed through the block of wood, and let's assume it hasn't taken any material with it, but it just has passed through, and now it has a velocity that's half its original velocity. So the block is moving, but just not as fast. What would then happen? Well, we could conclude that the block would not swing up. Well, I haven't done a very good job here, but this distance h prime would be less than h. In other words, this would not have as much momentum. Instead of all of the momentum going into the block, only a fraction of momentum goes into the block. That means lesser velocity. That means lesser kinetic energy and lesser potential energy. Here's another variation that sometimes happens. We shoot the bullet, into the block, and that means that the block with the bullet embedded in it is moving, and now we ask it to slide along a frictiony surface from its original location to some new location. So it slides a distance d, and maybe we know the coefficient of friction. So how would you handle this? Well, we would still use conservation of momentum in the collision to find v prime, and then we would use conservation of energy in the form of the work energy theorem. And what we would do is we would say that the kinetic energy of the block goes into work done by friction. So 1/2 of the mass of the block, let's just call it big M, times this v prime squared is going to equal the force of friction times the distance. Now, strangely enough, the force of friction is equal to mu times the normal. So this is going to be mu times m times g times d. And notice that the capital M's cancel, so that would mean that v prime squared over 2 mu g is going to be how far it slides. So that's something that you could do using the concept of the ballistic pendulum. So here, if top example is traditional. Second example, if the bullet goes through, it carries away some momentum, so this won't go as high. And then here's a one where the energy doesn't go into potential energy, it goes into work done against friction. So these are some variations that you should look for when solving problems.